So what we're doing is we're going over the homework now, and we're going to look at a couple of these specifically, numbers 9, 10, 11, and 12. So, number 9, what we have is we have 3 root 15 that's multiplied out in front of 3 plus the square root of 6. So we think of this 3 root 15, negative 3, as one big group of stuff that needs to be distributed through this expression. So this whole thing gets multiplied times the first term, and then the whole thing has to be multiplied times the second term in that expression. Yes, Roland?
Oh, I was just going to ask if you could also do 7 after you do all the other ones.
I might.
That one was easy.
Okay, so we're doing negative 3 root 15 times 3. So can I write it like this? Because we're multiplying those two, right?
Yes.
Do you see written this way instead of the reverse order that all we're really doing is 3 times negative 3? And that's negative 9 roots of 15. Does that make sense? Okay, then we're doing all of this times the square root of 6. So we're going to do negative 3 roots of 15 times the square root of 6. So this is, let me move it over here, negative 3 times the square root of 90. Well, doesn't 90 break down into 9 and 10? And the square root of 9 is 3. So this is negative 9 roots of 10. So it's simplified to negative 9 roots of 15 minus 9 roots of 10. That is number 9.
Yep, that's not what I got. Where did 19 go? You do 12.
I'm going to do 9, 10, 11, and 12. Okay? So that was number 9. Then we'll go back and do number 7. Okay, number 10. We'll start it over here. Number 10. Square root of 10 times square root of 2 plus the plus 4. Not even square root of 4. So we're just going to distribute here. Square root of 10 through this expression. So square root of 10 times square root of 2 is square root of 20. Plus square root of 10 times 4 is 4 times square root of 10. Well, square root of 20 breaks down into 4 and 5. So this is 2 roots of 5 plus 4 roots of 10. Ta-da! There's number 10.
I could have done that.
Hi.
Okay?
Could have done.
Number 11. Several different methods for working this problem. And I'll show you the first one. Is it fair to take this expression and write it like this?
Yes.
Yep, this is 5 times the square root of 8, and this is 5 times the square root of 18. Isn't this the same thing?
Yep.
5 fourths times the square root of 8 eighteenths. Does 8 eighteenths simplify at all?
Yes.
Yes. What number divides into both 8
9.
and 18?
2.
2. And, well, we're going to get a 9 in just a second. He was jumping the gun. All right. So the square root of 4 is 2, and the square root of 9 is 3. So it simplifies to 5 fourths times 2 thirds. Well, when we're multiplying fractions, can we just simplify? Can we say that 2 goes into 2 one time, and 2 goes into 4 2 times? So that leaves me 5 times 1 over 2 times 3, 5, 6.
Did you get the right answer? Oh, that is so cheap.
Okay. Yeah, I heard it, and this will be on the no calculator portion of your test. No, nada, none.
I just don't really understand the fraction part. I got all of them.
What happens now, Mr. Extra Credit?
All right. Okay, what I'm going to do on this one is I'm going to use the same philosophy with this one. I'm going to break this down into 5 times the square root of 15 over the square root of 20. Does everybody buy that that's the same thing?
Yeah.
So this is the same as 5 times the big square root of 15 over 20. Well, doesn't this simplify by 5?
Yeah.
5 goes into 15.
Trace.
3 times 5 goes into 24. So we know the square root of, we know the square root of 4 is 2, and we don't know the square root of 3. So it becomes 5 times the square root of 3 over 2, which 5 is just really 5 over 1. So the 5 goes up top. And there you go. Okay. We got back our benchmark scores. I already knew what your benchmark scores were. But what I got back was the comparison of how we did versus the rest of the county. And I feel like we should be leaders in this county. I want to set the bar high and you guys achieve. But on the algebra portion of the last benchmark, we underperformed compared to the rest of the county. And I don't want that to happen again. So I'm going to do a little more on my end to help us be better prepared. And I'm going to pull those benchmarks, the last 2, and look at the areas in which we were weak and help us to get ready for the test that truly counts for you guys, the end of course test, because that counts as your final, right? I do feel that you've mastered most of the topics that we have done this year, but I also want to make sure that if we were to have a higher level thinking problem in which you had to do some algebra, which is usually what these problems turn out to be, that you know how to start the problem. And I also want to make sure our algebra skills are fine-tuned. So we're going to work on some of that. I might give us some warm-ups that help prepare us for that. And on the next benchmark, I would like us to be the leaders.
So did Sandy Creek beat us too?
All I could see was Starr's Mill in comparison to the county as a whole.
Okay.
And
So probably not.
I could tell by the percentages that we were not a leader.
We were like
One in Terrasante.
In one of the categories, the county average for excellence was like 52%, and we were like 31. Big gap. So we're gonna work on that. Make sure we're ready, okay. So if I start maybe pushing the bar a little higher, please know why. I want you to be as successful as you can possibly be. We have a room full of bright students, and I want you to show that and perform well on tests. Okay? All right, and part of that is just this. Can I do basic operations here? Because this could be involved in an algebraic problem. So can I do this simplification of radicals? All right, somebody asked for number 7, so we'll go back to number 7 real quick. And then that'll be it for this page, and then I'll flip over to the rest of it. All right, we have the square root of 15 times -4 roots of 10. Okay, we can just multiply the radical, and we get 150 here, and then 150, you ought to tell that 25, because a quarter goes into $1.50 6 times. And then the square root of 25 is 5, so it comes out and it's multiplied, so we get -20 roots of 6. That was for you, Ron. We good?
Yeah.
Okay.
You get it now?
I get it now.
Good.
Get the right.
Okay.
You're looking at the wrong thing.
All right. And then, oops, there's some of the last ones worked out. But let me get rid of that.
No, I did it right.
Okay, you check the ones at the bottom, and then I'll do 1 or 2 of those. Yeah. Now I don't have one, but you have one. You're good.
I'm gonna put you square.
Hey, that's water.
I'll put you for that too.
Oh, I'm supposed to be checking these.
Did I ask for the AP sheet yet?
No.
In this class? Okay. Probably many of you will be applying for AP classes, and those of you that are not currently in a history class, if you're applying for AP World, I think they ask for a math
That's wrong, even if you are pre-qualified.
recommendation.
Yeah.
So I will be getting plenty of those in the next 2 days. I'm leaving them right here in my bin, and I'm going to take them home I'm not going to take them home. I'm going to stay after school Friday afternoon and do them all. So if you have them today, make sure that it has both your signature and your parent's signature. It has your name printed legibly, and it has what class you're applying for on it, so I know how to fill it out. If you don't have those with you today, I would love to have them tomorrow because I'd like to stay after school tomorrow.
What are these?
Wrap those up. Those of you that are applying for any AP courses or application courses that might need a math teacher recommendation. AP World, I think, is the big one for next year.
Do you need math recommendation for that?
If you're not in the Woodview class, then
Right.
you need math and English.
There's
You
AP
can
World,
do
there's
a
AP Art and Student
you get a
World.
recommendation from Gallon.
Yeah, those are the only AP.
I'll get one from her.
There's AP stuff.
You're not in class.
Yeah, we're not going to do
How
that.
many AP classes?
Yes, ma'am. Number 16?
You need two.
Okay.
That's
what you said, right.
Or, and
All right, number 16. So number 16, what we're going to do is we're going to break down that 18 into 9 and 2. Because 9 is the largest perfect square that divides into 18. And then we're going to break the 54 down into 9 and 6. So those of you that were out on Tuesday, all we did was add the adding and subtracting. To add and subtract radicals, you just have to have like radicals. Just like to add and subtract variables, you would have to have add x's with x's, y's with y's. Well, with radicals, you can only add and subtract radical terms that have exactly the same thing under the radical. So this simplifies here, and the 3 comes out. This simplifies here, and a 3 comes out. So this gives us negative square roots of 6 plus 6 square roots of 2 minus 9 times the square root of 6. So we do have some like radicals here. We have the square roots of 6. So this is understood to be negative 1 square root of 6, negative 9 square roots of 6. That's where the negative 10 root 6 comes from. Plus 2 times the square root of, plus 6 times the square root of 2. And we cannot combine those because they are not like. That's all you missed. All right, what else on this page?
19.
All right, Donald. We'll do 19. Okay, a couple different ways we could do this one. We could simplify the square root of 21st. Okay, and that would break down into 4 and 5. So what we would have is negative 2 plus 3 roots of 3 over 2 roots of 5. Is everybody good with that? Okay.
Adding for radicals is just combine like terms stuff.
And then, because we can't leave the square root of 5 in the denominator, we have to clear that, rationalize it, by multiplying the numerator and denominator by the square root of 5. So that's going to distribute the square root of 5 through the numerator, and the square root of 5 times the square root of 5 is just 5. So that's how my denominator turned into 10, because 2 times 5 made the 10. Okay, then I'm going to distribute the square root of 5 through the top, so that gives me negative 2 roots of 5 plus, all right, square root of 5 times square root of 3 is square root of 15. Okay? All right, anything else?
Don't push my head down.
Don't touch it.
Anything else? Nope. All right, let's move on.
On the for neutral down and then
I missed numeric
on
20.
the first part you did it's 2 the square root of 5 and then
Yep,
you
negative 2
multiply that
times the square root of 5 is negative 2 times the square root of 5.
on,
And the bottom part just ends up being 2 times the square root of 5. Well, the square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 is 5. And 2 times 5 is 10. So that's where this answer came from. Okay. Okay, so I am excited about the fact that some of you took notes yesterday, that you watched the videos yesterday. I wish I had. There we go. Okay, so let's summarize what you learned quickly yesterday. Let's say we had the point 1, 2. And we have the point 1, 2, 3, 4, 5, negative 1. And we were asked to find the distance between those 2 points on the coordinate plane. So probably some of you did something similar to this in middle school. Did y'all take this and draw a little triangle? Turn it into a triangle.
Yeah.
Oh, that's terrible. Hold on. Undo. us think of Pythagorean theorem. A squared plus b squared equals c squared. So we can think of this as a, and we can think of this as b, and this distance is our c. So if we were trying to find c, it's the square root of this, isn't it? So the square root of a squared plus b squared is equal to our distance, usually represented by a d. Now, when you learned the distance formula yesterday, there was no a squared and b squared in it. It wasn't. But if we look at a, this a, let's count. A right here. Did I put it on invisible ink? I must have. Let's try again.
It's just very good.
Huh. Maybe I won't undo that. If we look at this distance from here to here, this is 1, 2, 3, 4 units horizontally. Make sense? So this A would be 4 squared when I plug it in. This distance B is up 1, 2, 3 units. So that would be 3 squared. So we know that this distance is the square root of 4 squared plus 3 squared, the square root of 16 plus 9. 16 plus 9 is 25, and the square root of 25 is 5. So the distance is 5 units. Now, what if we have one like this, where the points weren't very close, and I gave you huge numbers? We'd have to use the distance formula, something that works every time. So let's think about how we could look at this A in terms of something that will work every time. Do you see that this distance is really just, this is 4, it's the difference in our x's. What is 5 minus 1? 4. So this A could really be represented by x2 minus x1. 1 point minus the other. The x value of 1 minus the x value of the other. Let's look at this. 1, 2, 3. What is 2 minus negative 1? 3. So do we see that this could be represented by this? Now, some of you are saying, wait a second, you switched the order on me. Well, this was actually negative 3 if this was my second point. But what does the squaring do to that negative? It makes it positive. So if we think of A as being x2 minus x1, oops, and the B as being the difference in our y's, y2 minus y1, this is our distance formula. The distance is equal to the difference in your x's squared plus the difference in your y squared. And that was a big chunk of yesterday's lesson, wasn't it?
Yes. That was almost all of it.
Except for midpoint. All right, now, if this makes sense to you, then you're not really memorizing. You just know what to do. This is a formula, though, that you could just memorize and be able to apply. Okay, boys, I think I'm going to have to break y'all up. Yeah, we're getting a little distracted. Okay, now the next thing you were asked to do was to find the midpoint or discover the midpoint. Well, does it make sense that the midpoint is just averaging your x's and averaging your y's? The midpoint just averages. And that makes sense. When I average something, doesn't it take me to the middle? Yeah. Okay, so if we had these 2 points, the points 1, 2, and 5, negative 1, the midpoint would be 1 plus 5 divided by 2, comma, 2 plus negative 1 divided by 2. So the midpoint is 6 over 2, which is 3, and 1 over 2, which is 1/2. Does it look like the middle of this line is about at 3 1/2?
Yeah.
Wow, that's not bad considering I freehanded all of that. And that's the midpoint between these 2 points. Okay? So, great. All right. Another problem may have given you a midpoint. Let's say the midpoint of a segment is the point 4, 2. And it may have given you an endpoint is the point 2, negative 4. Let's change it. Negative 5. That'll be good. All right. Find the other endpoint. Okay, 2 ways we can do it. This is the way I taught it with SAT class. And I kind of thought about it like this. Even though they're not on a nice little x-axis like this, I would say, all right, the midpoint is the point 4, 2. That gave me 1 point is to -5. So the other point's going to be an equidistant on the other side of this midpoint. So what do I have to add to my x's to go from 2 to 4? 2. So to get to the other endpoint, what would I add to the midpoint? 2. So what would the x value be? 6. All right. What do I add to the y value to go from, excuse me, it's hard to see that, -5 to 2? 7. So I'm going to add 7. What is 2 plus 7? 9. Okay? This is how I taught it when I taught the SAT class. Now, another way you can think about it is, go back to that midpoint formula. I know if I add up my x's and divide by 2, and and add up my y's and divide by 2, that gives me the midpoint. So this x value at the midpoint came from doing this. So if I know one of the x's is 2, but I don't know the other one, but I know when I divide by 2, it better equal 4. Could you solve that? Yeah. And guess what we get? 6. Because isn't 6 plus 2 divided by 2 4? Yeah. All right? And then we could do the same thing with our y's. We could say, this time we want it to equal 2 because that's what our y value is at the midpoint. So we know that one of the endpoints, the y value is -5. So -5 plus another y, when I average it, I get this. Well, if I multiplied by 2 and then added 5, do I get y is 9? Did I get the same answer? Yes, you pick your method, whichever one makes more sense to you. Okay? All right, now, the other thing we need to talk about is what was supposed to be today's lesson that I was going to leave you. But there's really nothing new about it, but there are a few little things I want to go over. All right, parallel lines. You had like a whole unit on this last year. Do you remember that? Parallel lines have the same slope. Perpendicular lines, the slopes are opposite reciprocals of one another. And there are 3 forms that you were given lines in. You were given lines in slope-intercept form, y equals mx plus b. Standard or general form, ax plus by equals c. And you were given them in point-slope form. Now, my summer work had them in all 3 forms also. So you got practice with it again then. So if you were given this equation, y equals 2x plus 3. The slope is this coefficient here. So if you wanted a line that was parallel to that, what would the slope be? 2, the same thing. But if you wanted a perpendicular line, it would be what? -1/2. Opposite sign and reciprocal. All right, this is in standard or general form. So 3x plus 4y equals 8. Now, most of you just rewrite it in slope-intercept form, don't you?
Yes.
But did you know that the slope is always going to be the opposite of this divided by that? Because isn't that what happens when we move it into slope-intercept form?
Yes.
So some of you may have had a class where you memorize this, that the slope, when it's in standard form, is -a over b. Anybody have one of those classes? Okay, yeah, a couple. And then the y-intercept is just this divided by that. So the slope of this is going to be -a over b. So what is the slope of that line? -3/4. So a perpendicular line would be positive 4/3. Opposite sign and reciprocal. Okay, this last one is in point-slope form, and it may have been the one y'all were least familiar with until you got here, but we did point-slope form in our first unit also. So we know that this is our slope, this is our point. So the slope of this line is 1/3. So if we wanted a line parallel to that, it would be 1/3. But if we wanted a perpendicular line, what would it be?
3.
-3. All right. Last thing I'm going to talk about is this. If they give us a equation for a line, and they give us a point, and they want us to write a line that is parallel to this line, which passes through the given point. Well, all we do is pick off the slope and plug it into point slope. So we pick off the slope, and then we plug in the point. The point is 2, negative 3. Well, minus a negative makes a positive there. If they ask for a perpendicular line, what is the only thing that would change right here? If they ask for a perpendicular line, then that would change to what? Negative 1/6. Negative 1/6. Okay, your homework is written on the board. You have the remainder of class, and then you can finish it up in IF. Yes, ma'am. Oh, whoa, one more thing. I'm going to check yesterday's classwork that you finished for homework. I'm going to check distance and midpoint and parallel and perpendicular homeworks tomorrow. Both assignments tomorrow. I'm not checking the distance and midpoint because there were a few things I want to go over before I graded you on it completion for that.